Hello and welcome back to the channel. This is episode 7 of the linear series where we're going to take a look at solving one variable absolute value inequalities. We're going to look at 3 examples in this video. The 3 examples are on your screen now. So if these problems look like what you're currently working on, then this is the video for you. So we're going to go ahead and jump into it with our first example. Now we want to solve these just like we did when we solved it with an equal sign, and then we'll look at how it changes with having an absolute value and an inequality together. So I want to isolate the absolute value onto one side of the inequality, so I need to move this -8 to the other side. We do this by adding 8 to both sides, and we have 10 is less than or equal to the absolute value of x. Now, because we have this absolute value and this inequality, I really want the absolute value of x to be on the other side. Right? And we know from previous videos how to rewrite this with an inequality so that the x is on the left. We do that by switching the sign. So instead of having less than or equal to, we're going to have greater than or equal to. And I go into more detail in a previous video when we first did absolute values, or excuse me, inequalities, if you want to go and watch that to see the explanation. So from here, we're going to split it up into 2 cases, just like we did when there was an absolute value and an equals. Meaning I'm going to have x is greater than or equal to 10, and I'm also going to have negative x is greater than or equal to 10. Now, this is where things get a little bit different. Because I have this symbol, because I have greater than, this is going to make my 2 inequalities a compound, and we're going to be using or. So I'm going to be looking at when is x greater than or equal to 10, or when is negative x greater than or equal to 10. This would also be true if we had a greater than symbol. Right? So if we have an absolute value is greater than some number, we're going to split up into 2 cases like normal, and then we're going to have the compound word or between them. And this is true for greater than and greater than or equal to. Alright, so this first one is already solved. The second one, we just need to divide both sides by a -1 to isolate the x, giving us x and -10, and then the symbol between them is going to flip because inequalities change when we both multiply or divide by a negative number. In this case, we're dividing by -1, so it's going to flip from a greater than or equal to a less than or equal to. Alright, so we have our 2 solutions. X is greater than or equal to 10, and x is less than or equal to -10, so we're ready to graph them. Looking at x is less than or equal to -10, it is a less than or equal to, so we're going to put a nice big closed circle. And with it being less than, I'm going to be looking at everything to the left. Then we also have x being greater than or equal to 10. So we can put 10 on our number line. Again, it's greater than or equal to, so we're going to have a closed circle. And greater than means to the right. Our compound word is an or, meaning we're looking at both solutions together. We're bringing them together. Okay, so it could be either when x is less than or equal to -10, or when it's greater than or equal to +10. So these are our 2 solutions. The x greater than or equal to 10 and the x less than or equal to 10, and then this is the graphed solution. Looking at our second example, we have the absolute value of x plus 5 is less than or equal to 10, and we're going to do this exactly the same way we just did it. Right, we're going to take the 5 that is not in the absolute value and move it across the inequality by subtracting it, giving us an absolute value of x is less than or equal to 5. And then we can split this up into our two cases, where we have x is less than or equal to 5, and we have negative x is less than or equal to 5. Now, because this is a less than symbol, the compound word we're going to be using is and. And this is true for any less than or equal to or less than. And now we're going to solve this just like we do with compound inequalities. The left one is already solved. It's done. And the right one, we just need to get rid of the negative sign in front of the x by dividing by the -1. And just like in the last problem, it's going to flip the sign. So we're going to have x is greater than or equal to -5. We have the two solutions, and now we need to graph them. So x is less than or equal to 5. Because it's less than or equal to, we're going to put a closed circle. And it's everything to the left. X being greater than or equal to -5. Again, a closed circle because it's greater than or equal to, and everything to the right. Now, because this is an and compound statement, our final solution is going to be the 2 points and everything between them, because it's where our solutions overlap. It's where both of them are true. It's where x is both greater than -5 and less than or equal to -5. Okay, so our final graphed answer is the answer in green. Okay, we have one more example to look at. And in this case, we don't have just the absolute value of x, we have the absolute value of 2x plus 5 being greater than or equal to 9. Now this is already set up with the absolute value isolated on one side of the inequality, so we are ready to split it up into cases. The first case being 2x plus 5, exactly what we had, is greater than or equal to 9. And the second case is the negative situation, where we have negative 2x plus 5 is greater than or equal to 9. Because this is a greater than or equal to, we're going to be using an or as our compound word. So now we're going to solve both of these inequalities. The one on the left, we subtract the 5 over, leaving us with 2x is greater than or equal to 4, and then divide by the coefficient in front of the x, leaving us with x is greater than or equal to 2. The one on the right, we're going to distribute this negative sign through, giving us negative 2x minus 5 is greater than or equal to 9. Moving the negative 5 across by adding 5 to both sides, leaving us with negative 2x is greater than or equal to 14. And then dividing by the coefficient in front of the x, negative 2, which gives x is less than or equal to, because it flips the inequality sign, negative 7. So we can graph both of these solutions. It's a closed circle because it's less than or equal to, and it's everything to the left of negative 7. Or we could have the solution where x is greater than or equal to 2. So we have 2, we have a closed circle because it's greater than or equal to, and it's everything to the right. Alright, this is an or compound, so I can have either this solution or this solution. Them together make our final graph solution, and the two inequalities make our numerical solution. So I hope this video was helpful. If it was, please consider giving it a like and subscribing. It would mean a lot to me. Good luck, thank you for watching, and we'll see you in the next one.